Children, today we are going to discuss moment of inertia for the different shape. First we are going to see the ring and disc, rod, cylinder, sphere, hollow cylinder, metallic cylinder. These are the thing we are going to discuss. Okay. First we will see it's a moment of inertia for the ring. If you like my channel, please subscribe. The moment of inertia when the axis is passes perpendicular to the ring. What is the inertia? Which value is given in the NCERT? The value of the inertia for this is equal to m r square. Okay. Now I am going to teach you how we can find these are the different places how we can calculate the inertia. Okay. So if you like my channel, please subscribe. The thing is the inertia at the edge of the ring and also which is perpendicular to the ring. I am taken like this. See here, I have the ring like this. So exactly parallel to this line. This line is perpendicular to the ring, exactly parallel to this line. I am going to calculate what is the inertia at this point. Inertia is equal to question mark. So I am going to use the two theorem. Okay, for this purpose I am going to use as a parallax theorem. The another time when I am going here, this place I am going to use as a perpendicular axis theorem. Okay. See, when it is axis is moving here, when the ring is getting rotate like this, now what is the inertia? I am going to use as a parallax theorem. The radius of the ring we can take it as the r. The ring radius we can take it as the r. I am going to use as a parallax theorem. So parallax theorem, total inertia is equal to inertia at center of mass plus mx square. It is a parallax theorem. So here x is distance between the two parallel lines. So distance between the two parallel lines, x is equal to r. So it is a radius of the ring. So the total inertia is equal to inertia at center of mass. Already we learned inertia at the center of mass is mr square. So mr square plus m. Distance between the two parallel lines is the r, which is going to be the x. X is equal to r square. So the total inertia is equal to 2mr square. So now we got inertia at this point. Okay, when the axis is at the edge of the ring, we got what is the inertia. Okay, now I am taken like a perpendicular to the this case. Perpendicular to this case, I am going to use perpendicular axis theorem. So we know already this line. Okay, I want the inertia at this side. I am going to use as a perpendicular axis theorem. So our perpendicular axis theorem is based on the two things. One is the inertia of z is equal to inertia of x plus inertia of y. So here I am going to take it as when the ring is rotating as x-axis and y-axis. When the ring is rotating like this or rotating like this, we can observe as like a sphere. Okay, when the ring is rotating like this direction, z-axis, I am taking this as a x, this as a y, this as a z. When it is rotating as a z-axis, it will look like a ring. X and y, it will be look like a sphere. So that means inertia of x and inertia of the y will be equal. This is a perpendicular axis theorem. Okay, x and y, inertia and x is equal to inertia of y. So that means we'll get total inertia at z-axis. I want the inertia at this point. Okay, that means x or y, x-axis or y-axis. Okay, anything we can take it. So 2 times of inertia is equal to inertia at z. Inertia at z already we know it is the mr square divided by mr square. It's a mr square. Okay, so inertia of z. So I am finding what is the inertia at this axis. So which is going to be a inertia at x. Inertia at x is equal to inertia of z divided by 2. Inertia of z is mr square divided by 2. So we got what is the inertia when the axis is passing like this. Okay, again. So the same diagram I am going to take it with the another way. I want what is the inertia at the tangential line for the ring. So in this point, what is the inertia? So already we know here it is this point. The axis of when it is rotating this point, the inertia is mr square divided by 2. I want here the distance between these two is the r. So the now inertia is equal to, I am using as a parallax theorem. So inertia is equal to inertia at center of mass plus mx square. Here distance between the two parallel lines is going to be r. So inertia at center will be mr square divided by 2 plus mx is going to represent as r. Distance between the two parallel lines, it's going to be r square. So this value will get as 3mr square divided by 2. The total inertia at tangential line to the ring will get as 3mr square divided by 2. So finally I completed fully what is the ring inertia. Okay, again I am going with the disc. So now disc inertia we are going to see. Okay, So I am taken as a disk. Disk, when the line is axis of rotation is passes perpendicular, the inertia is going to be a mr square divided by 2. Mr square divided by 2. The same exact parallel lines I am taken at the edge of the disk, which one is perpendicular to the ring. Okay, so exactly parallel to this line. So I am taken here, this which is perpendicular to the disk. Okay, so now I am using as a parallax theorem the radius of the disk r. So total inertia is equal to inertia at center of mass plus m x square. Here x is the distance between the two parallel lines, x is equal to r. So inertia at the center of mass m r square divided by 2, which one already we know. Okay, plus mx square, x will be r here, so r square we got. So this LCM totally will get us the mr square plus 3 mr square, 2 mr square divided by 2. Okay, this will get finally it is 3 mr square divided by 2. We got what is the inertia at edge of the disk, which is perpendicular to the disk. Okay, again I am going with the another way. Okay, so again disk, this way we are going to learn what is inertia at this way. When the disk is rotating this way, we will observe the sphere. When its disk is rotating, we will observe the sphere. When its disk is rotating at this way, we can observe its disk. Okay, so as the same thing, perpendicular axis theorem, inertia is equal to inertia of x plus inertia of y. So this two will be equal because two sides when it's rotating will get the same kind of inertia. So 2 times of I is equal to total inertia, inertia at z axis. Okay, so inertia at z axis already we know it is mr square divided by 2. It is inertia at z axis. Okay, so it is mr square divided by 2 is equal to 2 times of I. So I is equal to mr square. This I am bringing here, so we'll get mr square divided by 4. So the total inertia mr square divided by 4. Okay, now I am going to have the rod. So one lengthy rod is there. L I am taken length I am taken L. Exactly when it is axis passes through the center, ml square divided by 12 inertia. Okay, inertia at center of mass. So I want what is the inertia at the edge of the point. Here rod we are taken as a rod. Okay, so distance between this two, L by 2 and L by 2. The reason total L by 2, L by 2, just we made as a half of thing. This is the two parallel lines. I know it is the total inertia is equal to inertia at center of mass plus inertia at m x square. X is the distance between the two parallel lines. Two parallel lines is L by 2. So inertia at center will be ml square divided by 2. So ml square divided by 12 plus x, now x distance between two lines will be L by 2. So L by 2 whole square. Okay, this answer L square divided by 4 will get. So total inertia is equal to ml square divided by 12 plus ml square divided by 4. When we are doing this as a LCM, the inertia at the edge of the rod, so when the axis of rotation passes like this, the rod is going to rotate at the edge. Okay, here it's going to rotate. This is a point, it will be rotating like this. Okay, so when it's rotating like this, L square divided by 12 plus, I am taken as LCM 3 ml square. So it's going to be 4 ml square divided by 12. It's going to be, it is 3. So inertia is going to be ml square divided by 3. It's a final inertia when it is passes at the edge of the rod. Okay, again I have the solid sphere now. Solid sphere, when it is axis is passes exactly at the center, the inertia at the center of mass is going to be 2 mr square divided by 5. When the axis passes edge of the sphere, what is the inertia? Okay, distance between these two is the radius. So I am using now, it's a parallax theorem. So parallax theorem, total inertia is equal to inertia at center of mass, inertia at center of mass plus mx square. X is the distance between the two parallel lines, which is going to be the r. Okay, so it is 2 mr square divided by 5 plus mr square. So we'll get as a we can take it as a 5 as a LCM. It is 2 mr square plus 5 mr square. So we'll get as a 7 mr square. 7 mr square divided by 2. The total inertia when the sphere is rotating at this axis at the edge of the sphere, we can take it, it's a solid sphere, it is 7 mr square divided by 5. The same answer, 2 plus 5 will going to be the 7. Okay, again I have the hollow cylinder. When the axis is passes at the center of the cylinder, okay, the inertia is going to be mr square. So I am taken edge of the hollow cylinder. Now the axis is passes edge of the hollow cylinder. Okay, the radius of the cylinder I am taken as the r. Okay, so edge of the cylinder, what is the inertia? Inertia is equal to, I am using as a parallax theorem, ICM plus mx square. Distance between the two parallel lines is the r, so I is equal to, ICM will be mr square, which one already we know. Okay, plus mx square. X square is going to be here, it's a r square. Okay, so this is going to be 2 times of mr square, it's total inertia. When the axis is passes edge of the cylinder, the inertia will be 2 mr square divided 2 mr square. Okay, again I have the solid cylinder. Okay, solid cylinder, inside some matter is there, hollow cylinder, that nothing is there. Okay, here inertia will be mr square divided by 2. I am using as the same inertia is equal to inertia at center of mass plus mx square. Okay, x square is going to be distance between the two parallel lines, we are taken as the parallel line here. So distance between these two is the r. So I is equal to, ICM will be mr square divided by 2 plus mr square. So we'll get as a total inertia is equal to, it is when we are taken LCM, 3 mr square divided by 2. It's a final inertia when the axis is passes edge of the cylinder. Okay, thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.